All right, AP Physics students, this video lecture is going to go through that fifth problem from the application of Newton's third law problem set that we worked on Tuesday. This is another type of problem where we now have an interaction between two objects. In this case, it's two blocks. So what we need to do first is we have to look at this system as a whole. So we have to look at the two blocks together, essentially. So what we're going to do here is we first need to figure out what the acceleration of the system is. Now, to start that out, if we were to just write down our forces in our x direction, okay, the sum of our forces in our x direction, and we know that there's probably a change in motion there. So I have that 30 Newton force minus that 10 Newton force minus the force of friction, because we're told in this problem that there is a coefficient of kinetic friction there. So we have to figure out what that force of friction is. But first we need to figure out what the normal force is of this system, okay, the two blocks together. Well, that's easy enough to find here because Fg, which is equal to mass times our acceleration due to gravity, that's going to be equal to our normal force in this case. Okay, so we know that the total mass of this system is 5 kilograms. Multiply that by 9.8, and that gives us 49 newtons. Okay, so that's our normal force. So now, knowing our normal force, remember that force of friction here is just mu, or coefficient, times the normal force. Okay, so I'm going to find then that my force of friction is equal to 14.7 newtons. I'm going to plug in my mass here, which is the total mass, 5 kilograms, and we're looking for acceleration. So if we do this all out, we get acceleration is equal to 1.06 meters per second squared. Okay, so that's the acceleration of the system. That's the acceleration of both of those blocks. Now we want to find what that contact force is between the two blocks, essentially, because Newton's third law is telling us that in that interaction, the force is going to be equal and opposite. So really we want to just start focusing now on the 2 kilogram block and figure out what the force this 3 kilogram block is applying to the 2 kilogram block. But remember, it's going to be the same force. We could try and find what the force applied by the 2 kilogram block on the 3 kilogram block is. It doesn't matter. That force is the same, but we're just going to focus on the 2 kilogram block. So what we need to do then is, if we isolate that 2 kilogram block, I'm going to just redraw the image down here. If we isolate that 2 kilogram block.
There's a meeting taking place right now in Ms. Kale's room. Again, HOSA members, there's a meeting taking place at this time in Ms. Kale's room. Thank you.
I'm going to have this force F, so that force F is going to be the contact force. And then I know I have some force of friction. So again, I have 3 forces here. So the big thing here is we don't know this contact force. We know the 30 newtons that's being applied on the 2 kilogram block. Wow, I can't talk. Again, we need to find what this force of friction is. So again, it's just going to be the same process as we did above. So I'm going to have Fg is equal to mass times gravity, but again, that's equal to my normal force. So I'm going to plug in the things that I know here, and that's going to equal 19.6 newtons. Okay, so that's my normal force for this 2 kilogram block. So now we can start working in our x direction for this 2 kilogram block, and we can find what that contact force is, the force applied on the 2 kilogram block by the 3 kilogram block. Okay, so again, I'm going to do a summation of forces in my x direction. All right, so I have the 30 newtons minus my force of friction. Again, it's just going to be mu times our normal force. Mu hasn't changed, it's still the 0.3. So that gives me 5.88. And then minus that contact force. And then I have 2 times 1.06. And that was 1.06 meters per second squared. All right, so now we basically just have to solve. So I have my 30 minus the 5.88 minus the 2 times 1.06, and I end up with F equaling 22 newtons. Okay, so the big key with problems like this, where we now have 2 objects interacting with one another, the best place that we can start is to figure out what the acceleration of the system is total. Okay, and then we know then that this acceleration of the system, well, each block has to have that acceleration, and that makes it easy for us then to isolate blocks, okay, or objects, and analyze the forces acting individually on those items. Okay, so kind of an application of Newton's third law, understanding that we have this contact force because of the interaction there between the 2 blocks. So I hope this helps. If you have any questions on this, please let me know. Take care.